So for our final lesson in Unit 2, we are going to talk about the time it takes for our isotopes to disintegrate over time. And what we're talking about is our isotopes, remember, are unstable, okay? Or a lot of them are unstable. They don't want to be in the place they're at, just like you don't want to be unstable. So you do everything you can to stabilize your life. The same thing's going to happen with our isotopes. So our isotopes are going to shoot off different particles to become stabilized. And so that time is a fixed rate, and every isotope has its own half-life, and we can calculate that. So that's what we're going to look at today. So what is a half-life? Well, again, our isotopes are unstable, so they're going to go through that radioactive decay. So that nuclear chemistry that you did, where you shot off an alpha particle, a beta particle, things like that, that is, we're looking at the time it takes for half of your sample to do that. So all elements over the number 83, the atomic number 83, so everything from bismuth up is radioactive, meaning they're always going to undergo decay. They're going to go through that nuclear chemistry process of losing particles. So during the decay, the isotopes are going to lose either an alpha particle or a beta particle or some combination of both, along with energy. That's why we get gamma radiation and things like that at a fixed rate, okay? So at a fixed rate. And this rate of decay is a half-life. It is the time it takes for half of the sample to become stable or to change. So it's the time it takes for half the number of isotopes in a sample to undergo decay and become different stable elements. For example, if I have polonium-209, so polonium is number 84 on our periodic table, so it is an unstable radioactive isotope, okay? It is going to go through decay by giving off an alpha particle. So if you remember from nuclear chemistry, an alpha particle looks like helium, okay? It has a mass of 4, so that 4 is in that upper left corner, and it has an atomic number of 2 because helium is the second element. It has 2 protons, and the bottom number on the left is 2. So to go through alpha decay, it's going to lose an alpha particle, and it's going to become lead-205. Why? Remember, in nuclear chemistry, whatever happens on the left needs to match on the right. So 205 plus 4 gives me that 209. And 84 minus 2 is going to give me that 82, which is going to give me lead. Okay, so that is the process, and the time it takes for half of that sample to go from polonium-209 to lead-205 is your half-life. Okay. So how do we do this? Well, there's a couple ways we can, but the way that I have found to be easiest is to actually do a chart or a table. So I'm going to walk you through a couple, and then you're going to do a couple on your own. So here are your steps. First, you're going to draw a T-chart or a table. T-chart is just the line. Looks like a T. We've been making those for a while. Okay. On one side, you're going to label at the top time. On the other side, you're going to label amount. Under your time, you always start with time 0 because you're starting in the present. So whatever amount of sample you have to start with is always at 0. So 0 is where you start with time. Under your amount, you're going to put the starting amount given in your problem. Now, you have to be careful. Sometimes they may give you multiple answers or multiple amounts. So it's usually the biggest amount is going to be your starting amount. Okay? And then for every half-life, which means they've given you the half-life, they say carbon-14's half-life is 5,730 years, or polonium's half-life is 23 minutes. They will give it to you. They will tell you the half-life. So if it is told to you, you're going to divide the sample amount by 2 for every half-life. So if your half-life is 23 minutes, you go 0, 23 minutes, your starting amount was 100, so in 23 minutes, you'll have 50 grams. Then in another 23 minutes, which is 46 minutes, you'll have 25 grams. And we're going to see that in our problem coming up. Okay, so make your chart, time amount, start with 0, have your starting amount, and you're always going to divide by 2. That's why it's a half-life. You're dividing by 2. Everything gets cut in half. So here's an example. The half-life of carbon-15 is 2.5 seconds. That's a pretty fast half-life. If one had 100 grams at the beginning, so if I have 100 grams of carbon-15, how many grams would be left after 12.5 seconds has elapsed? So they're telling me my half-life. They're telling me how long I need to go. I need to figure out how much is left after I hit that amount of half-lives. So I'm going to make my chart, which I've done already for you. You can make one if you haven't, but on your paper you should have a chart that looks very similar to this. In the upper left box, write time. In the upper right box, put amount, okay? So one side's time, one side's amount, and we're just going to go down the list. Under time, I'm going to put 0 because I'm going to start in the present. Okay, so at my starting point, I'm going to look at my problem, and my problem says that I have 100 grams. So I'm going to put that in amount. I'm going to go through my first half-life. Okay, it tells me that the half-life of carbon-15 is 2.5 seconds. So I'm going to put my first half-life as 2.5 seconds. In 2.5 seconds, my amount is going to lose half of its mass, which means I'm going to divide 100 by 2, and hopefully you know that that answer is 50. Now, I'm going to keep going until I get to the time that they asked me to get to, which is 12.5 seconds. So I'm going to go and add another 2.5 seconds to my time, which brings me to 5 seconds. 2.5 plus 2.5 is 5 seconds. Because I go through another half-life, I'm going to take my mass that I had, and I'm going to divide it by 2. So 50 divided by 2 is 25. Okay? Still not at that 12.5 seconds, so I'm going to go ahead and go through another half-life. And you guessed it, since I go through a half-life, I have to take half of my amount, and so it's down to 12.5. I'm going to go through another half-life, which takes me to 10 seconds, and I'm going to divide by 2, and I get 6.25. I'm getting awfully close to my time, and so I'm going to go one more time through half-life. It brings me to 12.5 seconds, which is where I need to stop. So at 12.5 seconds, I go through half-life one more time. So 6.25 divided by 2 gives me 3.125 grams. So after 12.5 seconds, my original sample has gone through so many half-lives that of the original sample, I only have 3.125 grams left of carbon-15. So that's how a half-life works if you're given the half-life. Okay? Now, sometimes you're asked to find the half-life. If you're asked to do that, there's a couple other steps that are a little different. You're going to start the same way. You're going to draw your chart or table. You're going to label it time and amount. That stays the same. You're also going to start with time 0 because, again, we always need to start with our present. You're always going to start with the amount that's given. Okay, again, this is where you might see 2 amounts, and you always want to put the larger amount starting first because you're going to divide in half. So if you're dividing in half, you always have to start with a bigger number. So you have your starting amount at the top, okay, with your 0. You are going to divide that amount by 2 until you get to the amount they tell you to get to. So if you start with 100 grams and they tell you to go to 25 grams, you divide by 2, and you divide by 2 until you get to 25 grams. Then, once you get to the amount, you count how many times you have divided. So how many times have you divided by 2? Okay, so if you divide by 2 by 3 times, then that's how many half-lives you've gone through. You've gone through 3. If you divide by the number 2 6 times, you've gone through 6 half-lives. That number of half-lives, you're going to take it and you're going to divide it into the time elapsed, or the time it took. So your problem should tell you that in a certain amount of time, you've gone from 100 grams to 25 grams, okay? And then you're going to take that time and divide it by the number of half-lives you went through. And you'll see that in our problem next. Okay, so here's our example. After 56 days, that's the time it took, 8 grams of an original 128 milligram sample remains. So I started with 128, I'm down to 8 after 56 days has elapsed. What is the half-life in days of our sample? So again, I'm going to make my chart, okay, which I've already done. I'm going to put in time and amount, okay, right? Same steps as before. I'm going to put my 0 in. Now I'm going to look at my problem, and I have 2 masses. I have 8 milligrams, and I have 128 milligrams. Again, because I'm dividing everything in half, I'm going to put the bigger number at the top. So 128 milligrams. Sorry, I put grams, but it's milligrams. Okay? And I'm just going to go through now, and I'm going to cut in half until I get to 8. I don't know what the half-lives are, so I can't do my time yet, but I can keep cutting in half until I get to 8. So 128 divided by 2 gives me 64. 64 divided by 2 is 32. 32 divided by 2 is 16. And 16 divided by 2 is 8. Okay? So I just took my original sample and I cut it in half until I get to the amount that they tell me to end with. So 8 milligrams. So now I'm going to go ahead and count how many times I've cut. So from 128 to 64 is 1. 64 to 32 is 2. 32 to 16 is 3. And 16 to 8 is 4. Okay? I also know the time elapsed, which is 56 days. So I'm going to put that at the time for 8 grams, or milligrams, excuse me. So now I'm going to take that 56 days, and I'm going to divide it by 4 because that's how many cuts I made. I made 4 cuts, okay, or 4 halves. So 56 divided by 4 is 14 days. So the half-life of this sample is 14 days. Okay? On your paper, you have about 6 practice problems, excuse me. On the next slide, at the end of this PowerPoint, is all the answers. So you'll have the answers. You just need to work backwards to make sure you get there. So you can practice the different ways and the different techniques to find a half-life. Okay, so here are the answers for those 6 questions. Okay, but you need to show your work so you understand what is going on. Okay? So remember, a half-life is the amount of time it takes for a sample to undergo radioactive decay and lose half of its sample by becoming a different stable isotope.